Hello everyone, in this video I am going to discuss about average value of an alternating quantity. And the average value of any alternating quantity is defined. The average or mean of all instantaneous values. The average or mean of all instantaneous values of the alternating quantity over one complete cycle. Over one complete cycle is called the average value of alternating quantity. Okay, the average or mean of all the instantaneous values of the alternating quantity over one complete cycle is called as the average value of alternating quantity. And the average value is also called as mean value. The average value is also called as mean value. Okay, and it is remember the average values are denoted by capital letters with subscript average. Suppose it is for current, it is denoted by I average. Suppose it is for voltage, it is denoted by V average. Remember, the average value is also called as mean value. Average values are denoted by capital letters. And with subscript AVG means average value. Suppose current, it is I average, voltage, it is V average. Okay, the average value of an alternating quantity is expressed as, okay, now, summation of all instantaneous values over one cycle. Summation of all instantaneous values over one cycle by number of instants in that complete cycle. Okay, and in other words, the average value of alternating quantity can also be defined as the total area under the curve. Remember, total area under the curve of the waveform for a certain time period divided by the total time period. Therefore, average value also defined as area under the curve by total time period. Remember these two formulas. Anyone, average value, it is the summation of all instantaneous values over one complete cycle by the number of instants, or average value is equal to area under the curve for certain time by the total time period. This is the simple definition of average value. Next, in practical, to calculate the average value of any alternating quantity, there are generally the waveforms are divided into two types: symmetrical and unsymmetrical waveform. Then what is the mean by symmetrical and what is mean by unsymmetrical? Suppose I am considering one waveform here. Simple waveform. This is theta, and suppose this is the current waveform. And 0, suppose it is 5 and it is 2 5. The maximum value is, it is suppose 2 amperes, and negative also it is minus 2 amperes, and this is positive and this is negative. Suppose I am calculating the average of this symmetrical. This is nothing but symmetrical waveform, means positive and negative, both positive and negative off cycles having equal same period. Okay, now then if we are taking average of these two, plus 2 minus 2, this is the area under the curve. Total complete one cycle, area under of one complete cycle, positive 2 and negative 2, 2 minus 2, and the total instant, that is 2. Suppose 0 to 5 1 instant and 5 to 2 2 instants. There are 2 instants, and which gives 0 value. Remember, whenever you are calculating average for symmetrical waveform, which gives 0 average value, For that, if the waveform is symmetrical, we need to consider only one half cycle. We need to consider only one half cycle to calculate the average value. To calculate the average value, remember. We need to consider only one half cycle. This is very, very important while you are calculating the average value. Is it clear? Yeah. And this is about symmetrical waveform. For unsymmetrical waveform, suppose the waveform is unsymmetrical. Suppose the waveform is unsymmetrical. And positive and negative. These two are not equal. Observe here. These two are not equal. These two are not equal. Is it clear? These two are not equal. Therefore, the average of unsymmetrical value is not equal to 0. You are considering total waveform to calculate the average value. Total waveform to calculate the average value. Is it clear? Is it clear? For symmetrical, both positive and negative half cycles both are same, 0 to 5 and 5 to 5. Equal magnitude. Here unequal magnitude or time. Remember, the waveform is symmetrical. We are considering only one half cycle to calculate the average value of any alternating quantity, either it is voltage or current. This is very, very important to calculate the average values. Okay. Next, the average value of any alternating quantity can calculated by following two methods. One is graphical method, another one is analytical method. Graphical method, first one is graphical method. Here I am considering one alternating current. Okay, and this is symmetrical waveform. For that I am considering only one half cycle. See here, I am considering only one half cycle. In this one half cycle, there are 7 instants. Okay, now total number of instants are 7. And if you want to calculate the average general area under the half cycle by base time. Okay, now area, and suppose there are in one half cycle there are n number of instants. Therefore, x1 plus x2 plus xn. There are n instants by number of instants n. Here in this waveform, we are considering only 7 instants, x1 plus x2 up to x7 by total number. Base time is 7. Total number of instants. Is this clear? This is about graphical method. Next, coming to analytical method, this is very, very important. Exam point of view, analytical method is very, very important, and the formula is also. And for that, I am considering one sine wave, current waveform. Okay, now, and this is symmetrical waveform. For that I am considering only one half cycle. In that one half cycle, I am considering small portion of the waveform. By integrating this small portion of the waveform, I am getting the average of this entire symmetrical waveform. I am considering only small portion of one half cycle. That is dt. Suppose the area of this small portion is dt. I am integrating this portion with respect to this theta. Then I am getting the average value. Therefore, average value is equal to area of half cycle by duration of half cycle. Duration of half cycle is 0 to 5 and area is nothing but this one. I think everyone knows the equation of alternating current. I of t is equal to Im sin omega t. Where Im is nothing but maximum value of current. Therefore, I average is equal to integral 0 to 5 half cycle, only one half cycle, integral 0 to 5 I of t dt by duration of half cycle. Okay, now x2 minus x1, suppose t2 minus t1, like that. 5 minus 0. Then integrate this, we are getting average value. I am writing this as 1 by 5 integral 0 to 5. I of t is nothing but Im sin theta into d theta. Okay, where Im is constant, take outside. Im by 5 integral 0 to 5 sin theta d theta. Okay, and Im by 5, integration of sine is nothing but minus cos theta 0 to 5. Okay, and substitute the limits. Im by 5 minus cos 5 minus of minus plus cos 0, cos 0. That is equal to, otherwise it is not clear here. Yeah, I am writing here only. Im by 5 minus cos 5 minus 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 of minus cos 0, otherwise, right? Im by 5 minus cos 5 is nothing but, oh, sorry, this is not coming. Im minus cos 5 minus minus cos 0. Okay, minus cos 5 which gives plus 1, and minus minus plus cos 0 is nothing but 1. Okay, is equal to Im by 5. Okay, and 1 plus 1 equal to 2. 2 Im by 5. 2 Im by 5. This is the average value of alternating symmetrical quantity. Average value of symmetrical waveform. Average value of symmetrical waveform. Average value of symmetrical waveform. 2 and 2 by 5 the value, therefore I average is equal to 0.637 Im. 0.637 times of maximum value of current. 0.637 times of maximum value of current. Okay, this is the average value of this alternating quantity sine wave. Once again, simple, and average value is nothing but area of half cycle by duration of half cycle, and we know the alternating current equation. I of t is equal to Im sin omega t. I of t is equal to Im sin omega t, and therefore I average according to the formula integral 0 to 5 I of t d theta, and by base 5 minus 0. Therefore 1 by 5 integral 0 to 5 Im sin t d theta. Okay, and Im is constant, take outside. Im by 5 0 to 5 sin theta d theta, and integration of sin theta is nothing but minus cos theta, and limits 0 to 5, and substitute the limits. Minus cos 5 minus into minus cos 0. Minus cos 5 is nothing but plus 1, and cos 0 is also plus 1, and 1 plus 1 2. Therefore I average is equal to 2 Im by 5. That is equal to, I average is equal to 0.637 I max. Suppose it is voltage. Suppose they are asking to calculate average value of alternating quantity. Voltage, average voltage. Just we are writing V average 2 Vm by 5, or V average is equal to 0.637 Vm. 0.637 Vm. Remember, in the derivation we are calculating average value for current. Suppose it is voltage, same derivation. Suppose it is voltage, we are getting same equation. Okay, this is about average value of alternating quantity. Average value of alternating quantity. Thank you.